In this video, we're going to look at inverse proportion. So that's a bit different to direct proportion from the last video. And we're going to use an example with speed and time. So let's say if my speed was, let's say I was going a nice 50 kilometers per hour, a nice safe 50 kilometers per hour. And at that speed, let's say I got to my destination, however far away it was, in 2 hours. Okay, so my speed is 50 kilometers per hour, my time is 2. Now, if I were to go faster, what would happen? Well, I would decrease my time. I would get to my destination in less time. And the opposite's true. If I was to actually travel slower, it would take me even longer. So this differs to direct proportion because as I'm increasing one variable, increasing this one decreases. So as one goes up, the other one goes down. Now, the term here is inverse proportion. And it's different to direct proportion in two ways. It's different in the equation, the algebraic equation, and it's also got a very different graph. So first of all, let's look at the algebraic equation. So I'll just write up here, speed equals 50 and time equals 2 because we're going to use that. So the general equation, instead of for direct proportion is y equals kx, this is y equals k over x. But we do it the same way. We need to find out our k, which is our proportionality constant, and we do it by substituting in a value for y and its corresponding x value. And these are the two values we're going to use. So let's say x is our time and y is our speed. So our speed was 50, so we can substitute y equals 50 in there. And we've got k over the time, which was 2 hours. So now we've got an equation just with k, so we can solve for k here. So we multiply both sides by 2, and we get k equals 50 times 2, which is 100. Now, just a little side note, the 100 there is in kilometers, because our speed was in kilometers per hour, and our time was in hours. So we should get our k in kilometers. And this is actually the distance we travel. If we've got a fixed distance, if we're looking at fixed distance, and we're just looking at if we increase the speed, the time decreases, that's only true for a fixed distance. So a distance is a constant. And that actually reinforces how we call k. We call it the proportionality constant because that's exactly what it is. It is a constant. It's always going to be the same. And you might notice that if we multiply the speed times the time, it equals 100. That's also always going to be the case for inverse proportion. If I had to say a speed of 100 kilometers per hour, well then I could travel 100 kilometers in 1 hour. 100 times 1 is 100. So you're always going to have that pattern. That's just a little thing to take note of. Now, how would I draw this? Well, let's just do a rough sketch here. And let's say we've got time and speed. Now, like we were saying, if we have a really fast speed, it's not going to take very long to get there. It's going to take a lot less time. So with a high speed, we're going to have a low time. And as you decrease your speed, the time increases. But it's not going to look like a straight line. It's actually going to be more like that. It's actually going to be a curve. So this is going to get closer and closer to the axis, but it's never going to touch it. And same down here. It's going to get closer and closer to 0, but it's never going to quite reach it. So this is inverse proportion, a bit different to its direct proportion in terms of the equation and in terms of the graph. Now, the equation for this particular graph, we can write this with our equation by substituting in the k equals 100. So if we substitute k equals 100 in there, we get y equals 100 over x. And that is our equation for that graph.